Welcome to Grand Rounds. This is the first hybrid, and it's had all the technical difficulties you would expect. We'll gradually work to where we'll be more where the speaker won't be talking to the computer, but we'll be able to actually talk to the audience. We'll work on that. As always, I've tried to change the topic a bit. So what I decided to do is talk about how do you learn as a doctor, which seems to be a pretty important topic. In doing so, there are a couple principles I want to talk about. The first is be true to your roots. You got here in neurosurgery, the greatest profession in the world, for a reason. Don't suddenly start changing your principles, what you stand for. Be true to that. Second, most important thing, the whole lecture is stop, look, listen, pay attention. Begin to question, how do these things happen? How can we do it better? And tackle big problems. If we cover that, we've covered a lot today. Now, I did tell you that there are reasons to do this, and one of the things to talk about is how we got here, who we are, what we stand for. First of all, we're not just doctors, we're teachers, we're scientists. Put it all together makes a neurosurgeon. We're not just technicians, and that's really important. Probably the basic principle we talk about is we like our patients enough to want to do things better. If you keep track of that, you'll be fine in this and everything else. This has to do with roots and where you came from. This is where I came from. So this talk maybe will learn a little bit about me. People think I'm a good multitasker. I'm not sure that's true, but I'll tell you what I try to do to allow multitasking to take place. I'm from Chicago. I grew up after World War II. Massive city, massive crowds, everybody working class neighborhood. Everybody in our block either worked for Electromotive, which built diesel locomotives or trains, or for International Harvester, which built tractors, or for the big aluminum plant, for the quarry, the rail yards. Everything that made Chicago move took place there. It was fantastic. I learned a lot. My parents taught us about faith, family, and hard work, and that stuck. And we cared about it. We cared about each other. A lot of things took place in my life. I had a lot of sick relatives or relatives that were born with birth defects or things of that nature. That stuck. I wanted to do something about that, and I wanted to help people. Healthcare seemed to be unreachable, but I thought maybe I could do something like that. One point in my life, I was building houses in West Virginia and Appalachia. I learned a lot. I learned that life didn't just take place in the cities, but everywhere. I learned people were the same everywhere, same needs. I learned to stop, look, and listen. I've told some of you about this man here. This is the greatest carpenter I ever met in my life. He was phenomenal, and he had joy with his work, and he loved what he did. I learned that if you cared a lot and did something very, very well, you can be happy. It didn't have to be a rocket scientist or a neurosurgeon. It could be anything. But I became more and more interested in healthcare. An amazing thing happened to me, which we call scholarships. I went from lousy schools to great schools all of a sudden. I ran track at Notre Dame. I've got scholarships there. I got scholarship at the University of Chicago. I would walk to the hospital with a Nobel laureate, and it just changed my life completely. I became a neurosurgeon because it had everything to do with what I was interested in, which was care of the injured brain. And I began to tackle big problems. I basically found myself in West Virginia, again in the Appalachians, the stroke belt, because that was a big need of that area was stroke. It was neurologic. It was something that no one was doing anything about. And I thought we should. A lot of this started in Michigan. When I was there at the residency, I was surrounded by phenomenal people. The guy looking over my shoulder, you notice nobody wears any eye protection here. And you also notice I didn't use loupes because I was blessed with phenomenal close vision in those days. I really didn't understand why people needed loupes. As I got older, I need loupes. The guy over my shoulder is Kevin Lillihigh, the chair at Colorado. He was my junior. My senior was Steve Giannotta, the chair at USC. Phenomenal people, and they got me interested in big problems, stroke being one of them. We got to it by a technique, a tool, but we began to look at more. And when we looked at more, you do that by coordinating or partnering with people smarter than you. This would be really important. When I got to Kentucky, I got a large grant to found the stroke program for the state. Next thing I knew, we had half a dozen NIH grants. Everybody I hired had one. And we were beginning to look at this problem in a big way. Turns out that we had underestimated what stroke was. 11 million per year in the US when you look at cognitive decline, because we were thinking only about hemiparesis or blindness. When you begin to think about function, it made sense. I hired a guy that put together the NUN study. And this NUN study looked at the natural and unnatural aging of the brain in Catholic nuns who gave us their entire life history, followed their medical care, their brains when they died, and allowed us to do studies when they're alive. We found out that stroke and Alzheimer's were closely linked, and that the one triggered the other. It would double the rate of Alzheimer's in a nun if they had had a stroke. And if they had the pathology, they may not be demented unless they had a stroke. Had never been seen before. And I began to look at atherosclerosis because it was the tools of the time that I could study it. And that's the way. There was a problem. How do you look into it? You care enough to pay attention, to look and listen. You find the science of your time, which was this crude thing called ultrasound, and we began to study. I could tell you how thick the carotid was in its plaque wall. I could tell you whether you had heart disease. I could tell you if you had peripheral vascular disease, and I could tell you how much you smoked. I could follow my post-op. On the right is the suture line on a post-op carotid. I could really improve my techniques just by learning this tool. So I actually was one of the first people to qualify vascular labs. And the NUN study taught us more. We learned that there was a natural aging atherosclerosis, which we could slow. We could accelerate it by having diabetes, cholesterol moieties, or smoking. We could slow it down. And when we began to say, okay, if it's developed, if you started to develop atherosclerosis, could we do anything about it? So we thought, well, you must lower your cholesterol. So we did that with one group with diet. The other group, we found a new experimental drug, which you call a statin. We called it an experimental moiety. And when we used that, we cut the heart attack and stroke rate more than in half. So it was more than diet. It was more than a cholesterol number. It was the type of plaque. So we began to study the plaques. That was an embolus going by that you just heard. That embolus can be measured in the brain. You could actually hear it. There it is. And you could measure the plaque whether it was unstable. What we found was that you could actually quantify and measure. And once you did that, you could qualify the techniques. And then simultaneously, and this is about multitasking, people asked me to help them on a mission to Guatemala. I was their doctor. I said, sure, I'll go along because I wanted to do more. I was already working in Appalachia as I had started years ago. I was working with people of great need, but I discovered it happened everywhere. But I also discovered that the need was so overwhelming that I alone couldn't fix it. And if I needed to do something about that, I needed partners. But I did learn by looking and listening. I learned that people were urbanized, the rural population had no transportation, food and medical distribution, and the presence of war would disrupt the medical group. This guy on the right has just stuck his M1 through the window of my clinic. That really frightened me. And the people who saved me were the nurses who shooed him away. It was just amazing how just the force of good people could care. Um, Many lessons were learned. But what I did learn was that I couldn't do it alone. And I could not just serve. I had to teach doctors and develop a health system if I wanted to take care of healthy people. So I began to change. I began to teach doctors. And what we did was we went next to a country that was more stable and had a middle class that wanted to partner and began to teach. I brought nurses, nurses taught nurses, anesthesiologists taught anesthesiologists. I began to lobby the government to fund residents, began to set up the first residency ever in that country in neurosurgery, and was a great success. They don't need me anymore. They do it alone. And we're using them to teach other countries in that region. But I learned to listen. And a lot of what I learned was just by looking at their needs and listening to what they said. And I realized that everybody could teach you. When you walk into the clinic, watch the patient walk down the hallway. They're trying to tell you what's wrong. Look at their eyes, watch their gait, look at their hemiparesis, try to tell if they're depressed, see what their other medical problems are. Are they in cardiac failure? You are responsible for all of that. You're not a technician. The people who taught me that were children. These are my kids. Their first trip, they were loading boxes, taking care of people, and then they gathered over the years more and more training, more and more responsibility until my daughter ran the recovery room. It's amazing. She was so small that she couldn't find me when she ran into the ORs. They'd say, go get your father, somebody's sick. There was just a sea of people in scrubs, so she asked me to wear a red hat so she could find me. I still wear it today, and that's why. But I learned that we had to use distribution, we had to teach, we had to partner, and if I could make the country responsible for their own, well, shoot, that's what you do every day. If you can make your patients responsible for their own health care, their post-op recovery is immediate. They're happy. They're good patients on the wards. There's a reason that happens. You prepared them and had them take ownership. When the Ecuadorian doctors took ownership, they didn't need me anymore. But there are always challenges. The volcano erupts, the country falls, people steal things. Need is tremendous and relentless. The hydrocephalus program became a national, international need. And it was my partner, Ben Wharf, who went to Africa to tackle that problem. And it was people that we started together on this sort of thing. And the person on the left, of course, is Diane, taught me to take care of my own instruments. So what did I learn from that? Well, I learned to listen. Look, listen, learn. That's the first rule. Be quiet. The Sioux Indians say that speaking spills your knowledge. So listen, learn from that. Partner, you can't do it alone. Hire people smarter than you, like I did in Kentucky and like I've done here. Service, education, research are all patient care and tackle the big problems. What about stroke? What about my day job? Vascular neurosurgeon. Guess what? Our surgery was superb, but we were not decreasing stroke rates. So what's the science of the time? The science of the time at that time was genomics, gene chips. So I had the atherosclerotic plaques. I said, what genes make them symptomatic? Because asymptomatic plaque you can live with a long time. When it begins to break apart and embolize your brain, something I could measure with ultrasound, you began to see 247 genes differentially regulated, and they had themes: endothelial proliferation, new vessel formation, all are targets or biomarkers. And then these genes can become therapeutic targets if you know how to manipulate them. And yeah, we can, or the smart people we work with, our partners can. So here again is the plaque. And only now medical physics is telling us which plaques are unstable. These are the stress lines when your vessel pulsates. And that stress line along the surface is a highly unstable plaque. It correlates with emboli, correlates with cognitive decline. This is the people we should be operating on, not the narrows. but rather the unstable plaque. Changes the way we think about who should have surgery. And this looked at that strain and said it predicts exactly the emboli, just as that predicts the white matter changes and cognitive decline in people with multiple mini strokes. So we began to say, well, can you reverse it? If emboli are the problem with strokes, the treatable problem with strokes, could we reverse it? Well, we've got chemistry, biology, and imaging physics here. What we began to say is, could we make a concoction that would dissolve the clot? That's what you do when you have a clot in a vessel in your arm. You use plasmin to plasminogen to break it down. Could we speed that up? Could we make it and make it happen rapidly? And the answer is yeah. This is 1997. A 41-year-old school teacher comes in with left hemiplegia. She's wide awake talking to you and saying, is this going to be permanent? Now, and in 1997, we're not doing decompressive cranies because that was a barbaric operation which would leave them permanently paralyzed. And so they all died. But then you remember this person you went to med school, went to college with, who created this science stuff that would dissolve clots. And you say, can we put it in there with a catheter? And we could, and opened it up. It's a normal lady. This is fantastic. We'll do it on everybody. Turns out that drug worked on 4% of people. Only 4. The rest may have been harmed. But science of our times. We began to develop catheters that could snare the plaque itself without the drug. And in 2015, 4 studies showed 40% were improved by this. That just comes by looking, what are the needs? What's the pathophysiology? How do we make it better? So tackle big problems. Well, that can come back to haunt you because this group called Fiends called me up and said, we understand you're doing stuff in South America. Could you help Africa? 400 million people no neurosurgical training in sub-Saharan East Africa. I said, yes. Same problems. Transportation, distribution, same problems we have here. How do we get our stroke patients to the hospital? Well, we got helicopters, we got early intervention, and we're going to have sub-sites of stroke care as well. Partner regional people. We started outreach clinics to establish an infrastructure of nursing and ORs in the other major cities. And then the graduates began to be sent to those cities. One graduate can treat 4 million people, develop a stroke care, a trauma care, a cancer care, pain care, changes everything. Neuropathology, bring the first microscope to Nairobi and teach them how to do the first aneurysm. Now they do it independently, very, very well. Build ICUs, partner with the government. This is the president of Tanzania. He's saying he will put his budget into healthcare if we can make sense of it and organize it. Not just neurosurgery, but the whole system. Neurosurgery does not exist alone in infrastructure. Just as you don't treat neurosurgical problems alone, you treat the whole patient. This is a doctor, a friend of mine from Spain, who built this hospital in Zanzibar just for neurosurgery. Just if you can staff it, we'll build it. This is the old hospital. This is the new one. It's amazing. Just one person from Valencia did it all with a lot of encouragement. And then suddenly science came to this problem and actually did the numbers. The GIS, where the needs are. This is the scientist of geography now. And the Lancet Commission saying that 5 billion people lack health care. 47 million lives being lost. We think 6 million died of COVID, 47 million from not having surgical care. Suddenly, surgeons became not the bad guys, but perhaps the linchpin of healthcare. And that's important. The World Health Organization unanimously declared this was a global priority. I flew to Geneva to help them establish a global surgery education commission. And I asked them only if you do one on strokes, and now there's both. The stroke will devastate the developing world as we change their healthcare, their diet, their smoking for the worse. So now that's what's being done. There's over 27 sites now worldwide where we've established programs or support them in training, and we partner with the science of the time. COVID actually taught us to use the web to teach, get equipment grants, partner with organizations and companies, partner with governments, develop training scholarships which bring people here for finishing, but mainly scholarship them to be trained in Africa, in South America, in Southeast Asia, and now Central Asia, and then copy what we do here. Your education is being duplicated around the world. Neurosurgery boot camp started in the Senior Society 2010. I was the president of the Senior Society in 2010. And what I decided was I'd ask permission of the Senior Society. They were kind enough. Could we take it worldwide? So we started in South America, got 5 countries to participate, and discovered that they could teach the course if we taught them how. And they became confident. We did programs in Zimbabwe, South Africa, Myanmar, Bolivia, Chile, and took it all online. And it's always got challenges. Think about your everyday in neurosurgery. You're dealing with the most difficult problems in medicine. You're good at that. It's always 2 steps forward, 1 step back. There's always poverty. There's always war. There's always pandemics. Never stop. That's how you learn. You keep going, you keep trying. Because the challenges are at home. I refuse to say that, okay, treating strokes after they happen is good enough. What happens about, what have we done after the stroke happens? Nothing. Now I'm beginning to say we should repair the brain. Regenerative neurosurgery will be your future. And brain-computer interface, we brought all these wonderful scientists into our department. It'll be helpful. Transplantation, not in my lifetime, but regeneration of the brain. This is the way you make a brain in a fetus, and this is the same process in a brain of a stroke patient that tries to repopulate the area. Why can't we turn that up, turn that on? All we have to do is study what are the processes that the brain is made and repaired. You can determine that by genomics. Talk to those partners of yours again. They tell you which proteins are key. Study them first as biomarkers and second as ways to develop repair. And that's what we're doing in our lab now, copying the stem cells of birth into the ones in life. And these are the markers, galactin-3. It's important to make new vessels and survival of cells and neurons. Many others like that, and you can do it. But you have to understand you are in a capstone or a keystone. That's the thing that holds the whole arch up specialty. Without neurosurgeons, you can't have trauma care. You can't have cancer care, appropriate cancer care. You can't have complete stroke care. You can't take care of pain properly. You can't take care of congenital anomalies properly. We have to take a lead, not only in stopping damage, there's a subdural, I'll stop it, but preventing it and repairing the damage after it's taken place, because degenerative disorders of the brain will devastate our aging population as they do our congenital problems of children. Repair is going to be the next step. So how does it all come together? Well, in a pandemic, patients, what are their needs? These lessons are in your clinic every day. They're in our backyard. I study stroke, I study cognition. What population has the highest stroke risk factors in the United States? It's not inner city. It's not African American. It's not migrants. It's Native Americans living on reservations. We live in Wisconsin. We're surrounded by these. I began interested. Well, the elders of the Oneida tribe met with us and said, we have a problem, massive stroke rates, cognitive decline in our elders. Our elders are essential for our history, our language, our customs. Can you help us to maintain them? After years of working with them, building trust, we now have a program we're proud of, because what we're doing is working with them intensively to change their entire culture about diet, exercise, and adopt their culture again. The foods that they eat are far healthier than the ones we've provided, or our culture has. Their health practices, outdoors, exercise, etc., are what we're doing. We have programs to restart that. As a matter of fact, I'm doing a Just Move It Oneida health session this month, where we're all going to walk around the lake on the reservation as we give talks about what they can do to change their health care. At the same time, we're scientifically studying their rate of atherosclerosis. 87% of the elders have atherosclerotic plaque when 30% of Madison does. And what are the biomarkers or genomic factors that we've found that are important there? That's what's going on every day now in the labs, and they're partners in this to try to change it. So what does all this mean? What does it all mean? Well, it means you have to learn continuously, and you have to have principles that you follow. The background, probably the ones your parents gave you, are essential. But you have to want to like people enough to want to do it better. So if you want to be a great doctor, like what you do. Like everybody about you and embrace that. And then stop, look, and listen to what your patients are telling you. Because you have to be creative. You have to design new surgeries or new techniques. No neurosurgical case is like the last one. They all are different. Be creative about it. And you'll be creative. That's what research is. And you'll do it by partnering. And you'll do it by teaching. The very definition of the word doctor is teacher in Latin. And that's what we do. We will stagnate immediately if we don't try to learn and improve. And you are the teachers. That's why we hang around young people like you, because you are teaching us as much as our patients teach us. And integrity. I love that word because, as you know, I like the definitions of words. In Latin, it means whole. A doctor with integrity doesn't just treat the disease in front of them. They treat the whole patient. You don't take care of the brain without worrying about the heart. You don't take care about the patient without worrying about who will care for them when they leave the hospital. Will they have nutrition? Will they bounce back? You don't care about medicine without caring about whether your patients have access to care. So you might get involved in issues like that, and that's just fine. And you don't care about a disease without saying what happens to the patients who we did not reverse the disease. How do we repair that problem? And in the end, you hang around medicine because you get to hang around really great people who really set the example because they like their patients and they wish to do better for them. That's probably the most important lesson you'll ever learn about this profession called neurosurgery. Because the thing that keeps you going is your own personal code. This is mine. You should have your own. Patients, family, and values or faith. We serve patients every day. This family thing doesn't have to be people related to you. There are people that care about you and you about them that you can trust and be honest with, and they will correct you if you get off course because you need them. Don't ever lose them. Set aside time for the values that you think are important because it'll make you a better doctor. In the end, define yourself by what you do. What did I teach you today? Learn by listening, act creatively, teach, and you will learn and leave the world better than you found it. That's all I've got today. Thank you. I don't know.
Yes, Bob, that was great.
Thanks, Dan. Bring up questions if you have them. We will make this much easier as the weeks go on, as we get to a regular classroom. Okay. Listen, I want to thank everybody then, and we're going to break now, get on with our day. Thanks so much.